This lesson is for FST, lesson 4.6 on the tangent graph. We need to do a quick review of some of the values for tangent that we did back in the first part of the chapter. A quick reminder that when you do tangent, it's sine over cosine. And when you do sine over cosine for 30 degrees, you end up with square root of 3 over 3. When you do tan of 45, since the cosine and the sine are both the same, you end up with a 1. And when you do tan of 60, again it's sine over cosine, and you end up with square root of 3. Students want to know how those numbers came about. They would just simply set it up as, for example, square root of 3 over 2 divided by a half is what tan of 60 would be. And when you multiply that, or divide that, you end up multiplying by the reciprocal. And the 2's cancel there, so then you end up with just square root of 3. And then a similar fashion for tan of 30, you would just flip this fraction over. The only difference there being that you have to get rid of the radical on the bottom by multiplying by the radical on the top and the bottom. And again, students can ask for help on that if they so choose. We also need to review symmetry. Remember that symmetry for graphs is typically either even or odd. And just a quick reminder that the cosine graph is the even one and the sine graph is the odd one. Reminder here that even means they have vertical symmetry over the y-axis. Odd symmetry is symmetric about the origin, or rotation symmetric 180 degrees. When you're identifying the period of a graph, remember that's how long it takes the graph to repeat. And we're going to focus a little bit more on that word period here as it relates to functions in general, and then specifically we're going to look at the tangent graph itself. So the book talks about a little bit more detail about things that are considered periodic. If a function is periodic, then there is a number p such that when you add it to the function is the same as what it was. The smallest value for p is going to determine what the period of the function is. Now this is something that students have been familiar with and been doing so far in the chapter, but now they've given it an official theorem name here. So they've got the theorem listed here in both radians and degrees. And like I said, students have been doing this all along, but now it's an official theorem. So if you take something, for example, like the sine of 495, students know that that means you've gone around the circle more than once. And so you'd take away that extra circle, that extra amount, and so we know that the sine of 495 is the same as you doing the sine of 135. Those are both going to be in the same location on the circle. So if we know the sine is the y value at 135, we know we're in quadrant 2, and we know that the sine or the y value there is going to be positive square root of 2 over 2. So the sine of 495 just means we've gone around the circle once and then again traveled to the 135 location. So they would both have a value of square root of 2 over 2 for the answer. So students have done periodicity all along, it's just now been given a formal name. Next we're going to look at the graph of what tangent looks like. And so I've pictured here for you 2 periods worth of the tangent graph. Notice that it has a very strong resemblance to the cubic graph. The cubic graph kind of looks like a parabola on one side, and the other half of the parabola, instead of going back up, has been twisted and gone down the other direction. This graph, as opposed to the cubic, has asymptotes that are vertical. Those vertical asymptotes occur every 180 degrees, starting at the value of 90, or in radians, pi over 2. Typically the tangent graph is pictured with radians as the x values, but know that we could also graph it with degrees. So there's a asymptote vertically at 90 degrees, and then there'll be another one 180 degrees after that. So the next one would occur at 3 pi over 2. Those also go back the other direction, because remember you can go around the circle negatively as well. So there will be an asymptote at negative pi over 2 and negative 3 pi over 2. And then those asymptotes continue. So here I've shown one period and then a second period, but know that that wave shape continues with asymptotes in between each one. So when we're talking about the domain is going to be all x values here, so we would say all reals, except for where those asymptotes occur. So we're going to say that the domain is all reals except odd multiples of 90, or we could say pi over 2. And then we'll list the next one as well, which is at 270. And then we'll say dot 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 to indicate that those keep going. The range, you can see as you look at the graph vertically, is going to go up forever and down forever. So the range is going to be all reals with no exceptions. The domain has exceptions because there are asymptotes vertically, but the range does not have any asymptotes, so we can just say all reals. The asymptotes occur at 90, 270, or we could say pi over 2, 3 pi over 2, and then they repeat every 180 after that. Let's just put a little note here. The asymptotes will occur every time or everywhere that cosine equals 1. Excuse me, that cosine equals 0. So if you think about where that happens on the unit circle, whenever the cosine is 0, since tangent is equal to sine over cosine, anytime the cosine is a 0, you get an undefined answer. So that is where those asymptotes will occur. So if you can imagine where cosine is 0, then you'll know exactly where those asymptotes will occur. Since this symmetry bears a lot of resemblance to the cubic graph, its symmetry is indeed odd. The period for this graph, while it is not a sine wave, it doesn't have the same shape as cosine and sine, it is periodic in that it does repeat every 180 degrees, or if you said it in radians, you'd say every pi radians. A reminder here about the odd symmetry. Again, that means symmetric about the origin. It's just another way of describing odd symmetry. Basically, if you took your graph right now and turned it 180 degrees or looked at it upside down, it would look exactly the same as the graph you're currently looking at on the screen. So what you're looking at now is a complete picture in degrees and radians for exact values of tan and approximate values of tan. So as you start at 3 o'clock going around the circle, the tangent values will increase until we get to a cosine of 90 where we'll have an asymptote. Then the cycle starts over again and we get a nice cubic looking shape. And then we get another asymptote at 270, and then we get the other half of our first wave as we complete the full circle around 360 degrees. Students will not need to physically graph this themselves. Students should be willing and able to graph a quick sketch similar to what I've done here.